Yo, what's up guys? So today I'm going to be talking about my addition and subtraction functions for my Minecraft operating system. I'll talk about how I coded them and how fundamentally they're actually very simple. So let's get started. It all starts here. This is an 8-bit adder and it's very simple. It has two 8-bit inputs and one 8-bit output. So I can just input two numbers, so maybe a 5 and a 3, and I get my output, which is an 8. Now, this adder by itself is very simple. But how do I do this with my assembly program? Because remember, I don't input two normal numbers, I input two registers. And then I don't just leave the output floating there, I take the output and store it back into one of the registers. So how do I go about this? So let's go all the way back to like 6th grade math, where they might have given you something like this, where x plus 3 equals blank, and then they give you x. They say x equals 5. And I bet most of you guys could confidently say that this answer is 8. But how'd you guys get this answer? Well, you saw x is equal to 5, and you saw x right here, so you took x and substituted it for 5. And then you saw 5 plus 3, and you knew your math facts, so then you got 8. But what if x was different? And you have x plus 3 equals blank, but x is equal to 1. Well, you do the same thing. You see x is equal to 1, and you see x down here, so you put 1 there, and then 1 plus 3 equals 4. Now, why would I be showing you guys this? Well, it's because registers are a lot like variables in the way that they are a placeholder for a value, and that value is normally changing a lot. And then what you saw right here, this x plus 3, is an example of a formula. And no matter what x was, you would always add 3 to it. Now this is almost like our adding function, but we're missing one thing, and that is the other register. We're adding one register to another register. So I modified this formula, and we have something like this, where we have x plus y equals something, and then we have x equals 2 and y equals 1, and you guys can figure out that this answer is 3. But we're missing one thing here, and that is actually doing something with the answer. Right here, the answer, the output, the result is just kind of sitting there. So let's fix that. So here we have our answer, so we have x plus y is equal to our answer. Then we take our answer, which is a temporary placeholder, and then we put it back into x. Now this is really all our addition function is. We find our registers, x and y, we get the values for them, we add them up, we just follow the formula, and then we get our answer, and then we just put answer back into x. And all we have to do the subtraction function is just substitute this plus for a minus. So then we can just make a different formula for it, but use the same logic. We get our two values, x and y, and instead of adding them, we subtract them, then we take our answer and then put it back into x. But let's look at the code. So this is the code for my operating system. And so before I show you guys the adding and subtracting code, I want to show you guys one thing. And that is how the operating system decides which function I inputted. And so it is all decided in this block of code. Now, each function has a specific ID. And that ID is found by adding the two characters used to designate it. So if I were finding the ID for move, which is mv, I would add the ASCII values for m and v, so m plus v, and that's the ID for move. If I was loading, I would add L and D. If I was adding, I'd add A and D. So this is basically just a bunch of if statements figuring out which ID it is. If one of the IDs matches, it will jump to a specific part of the code that will run that function. Now all we're going to look at is this section right here. So we're checking the ID 133 and 149. And 133 is A plus D, and 149 is S plus B. And notice they go to the same place. And that is because the addition and subtraction function basically use the same code. The only difference is the sign used when finding our solution, either a plus sign or a minus sign. But we'll not forget these IDs because they're very important later. So this is the code for the addition and subtraction functions. So let's just go through it just chunk by chunk. So this very first part saves the function, the function ID, the sum of the two characters used to designate it. So either A plus D, 133, or S plus B, 149. So we save it here into R0 so we can use it anytime later. So then I get Y, and then I get X. And it's a little weird, but I'll explain why I got Y first and then X instead of X first then Y. Because there's a reason for it. So before we do the operation, we have to actually decide what operation we're doing. It's basically checking if the ID is the addition one or the subtraction one. If it's the subtraction one, it sets the ALU to subtraction mode. If it's addition, it sets the ALU to addition mode. Then these two lines right here actually perform the operation. They add or subtract the two numbers together, and then it saves the answer back into X. And this is why I had X opened last, because when you open a register, it doesn't automatically close it. And because I opened the first register, the X register, last, it is still open when I want to save the answer back into X. So I can simply just load the answer into RAM. And then this line here restarts the program, goes back to the beginning, gets ready for the next function. I hope this is kind of giving you guys a better idea of what's actually going on inside of my computer when I'm running all these programs. Next week I'll be talking about my file editor, so how I can bring up files, edit them, and then save them for later. So stay tuned for that, but that's all for now. Peace.